Yes,
Yes.
yes.
Okay, so as I was saying, Dr. Sisodiya sir is an esteemed academician at the Department of Computer Science and Engineering at National Institute of Technology. He holds a PhD in computer science and engineering with expertise in machine learning, soft computing, artificial intelligence, and biomedical image processing. His extensive research contributions span computational intelligence, recommendation systems, fraud detection, and brain disorder analysis using EEG signals. He has authored numerous high impact journal articles indexed in SCI, Scopus, and Web of Science, and co edited books on AI applications in healthcare and data analysis. Dr. Sisodiya has mentored numerous PhD and MTech students on cutting edge AI problems, and that has led to secure government sponsored projects on cybersecurity and AI driven modeling. He has organized several prestigious international conferences, delivered keynote talks on AI and machine learning. As a senior member of IEEE and ACM, he actively contributes to research community through journal reviews and conferences. So now we would invite Dr. Sisodia and we listen what he has to offer. Over to you, sir.
First of all, thank you very much, and my sincere apologies because I was not able to join on time. So I hope you will understand sometimes such type of situation is arise. So thank you very much for your patience and kind consideration. So without any delay, I would like to start the presentation. Is this screen is visible, sir? What I'm sharing is
Yes, sir.
Y-
okay. So I'll just change some few slides, or these changes are visible.
Yes, sir. Yes, sir.
Okay, okay, okay. Perfect. So uh, the this program is basically a recent emerging technologies for artificial intelligence and communication. So basically, I learned a little bit of AI. So my focus or the focus of this talk will be AI and the very specific the one field of AI, machine learning and its application. So this will be a general talk. So first of all, we start with this. You may have seen this diagram at various places. So this figure is basically this figure is visible. Hello, hello, hello.
Yes, sir. Visible, sir. Please continue.
Okay. So as we know that this how this AI technologies are disrupting our the whole technology landscape. And now you may be heard about the recent development, like recently, just few days before this DeepSeek, how they have shaken the Nvidia sort of company. So now this artificial intelligence is everywhere. Now you can say that everybody is talking about, and some recent every day some new thing is arise. And the recent example is this DeepSeek R1, which is a large language model, or you can say the very economic large language model, or very cheap as compared to the this Chat GPT of OpenAI. So how this DeepSeek R1 has disrupted. So this AI is basically a very large field. There are so many things are there, and like NLP, natural language processes, and this robotics, machine learning, then this intelligent agents, expert systems. So many things are there. Out of these, artificial intelligence is like how we can train. There are different levels of AI, and right now the development is on our second level, and still we have to achieve this super intelligence AI, and these intermediate levels have changed our life too much, and many redundant jobs they've already replaced. So learning is a one part of this AI, or we can say the machine learning is a one part. There are many machine learning algorithms are there. Broadly, these machine learning algorithms are classified in three categories: supervised, unsupervised, reinforcement. Then there are further deep learning, transfer learning, and active learning, online learning, offline learning. There are so many things are there. Out of this learning, one type of learning or one way of to learn from the data for any problem is neural networks. So there are again different types of neural networks are there, and these neural networks may be a deep or shallow. So further they lead to a very specialized network, which are known as deep learning. And now the deep learning is also, there are different types of deep learning network, like for vision purpose or for image processing. Preferably we use this convolutional neural network. For sequence processing or sequential data processing, like text processing, this recurrent neural network. And there are many advancement of this recurrent neural network which led to the transformer networks which are used in these large language models. So large language models, and these transformers are very powerful, which are introduced by Google in 2017 only, and now they are very much popular. And all these the architectures like GPT-4 or any other architectures are predominantly based on this transfer architecture. So in this way, we can understand now that there are many courses, BTech in artificial intelligence, even BTech in machine learning. Very soon, some may launch the BTech in deep learning or MTech in generative AI. So we can say nowadays artificial intelligence is basically a full-fledged engineering discipline, and there are so many things are there, and it is very difficult to cover all the things in one lecture. So this diagram, uh, there are so many diagram, but this, I think this diagram will appropriately capture the whole landscape of AI. That's why I included this diagram. So in this way we can understand the how this artificial intelligence is, and the basic, ultimately the objective of all these technique is how we can mimic the human brain like functioning in machines, or how we can design programs, softwares, or systems which behave like a human brain. Why we are interested in human brain? If we are, there are so many there are many powerful computing techniques are available. Yes, there is superiority of human brain in many cognitive tasks. Like nowadays, earlier it was very difficult. Now this chat GPT or such type of many applications are there. So they are generating new text, new voice. You may have seen this deepfake videos and all these things. So it is very difficult to distinguish between. So just to aid the brain-like functionality to these systems, this artificial intelligence plays a significant a role. And this the basic objective is to build the machine learning is means building machines that automatically learn from experience, like human brain also learn from the past experience. But in case of machines, this past experience is nothing but the data. So experience is gathered in form of data. This machine learning is a very old term. In fact, this AI machine learning, these are very old term. First time this machine learning was coined in 1959. So it's not a new field. But why this machine learning is emerging in last 10-15 years? Because of the availability of data. Data is like a fuel for all the this machine learning or in general AI models. So nowadays data is cheap and available in abundance. Data can be stored. There are storage technologies like earlier there was only file system, then relational database management system, then data warehouses. Now you find the data marts, data lakes, and there are so many things are available. Similarly, not only we are not dependent on only relational database, there are different types of NoSQL database, vector database, graph database. So any type of data, capturing any type of data, as well as storing any type of data, processing of any type of data is easy. And but still, just with the flood of this data.
यार एमटेक
Hello.
का भी तो सर जो ये वाला कोड दिया होता है उसी से बनाते हैं ना थ्योरी वाला
Okay. So, but still, with the availability of means everywhere is flood. Hello. Data is available in abundance, but still knowledge is expensive and scarce. So the challenging is how we can learn from this the huge amount of data, and can we perform the generalization. So this machine learning is like learning a general model from the data of particular example. There are many classical definitions are available of machine learning. There are many, but much simplest way of this ML is a subset of large field of AI that focuses on teaching computers how to learn without need to be programmed for a specific task. And one definition is given by this author Samuel, who coined this machine learning term. Machine learning is a field of study that gives computers the ability to learn without being explicitly programmed. Sometimes this machine learning is defined means like machine learning is the science and art of the programming computers so they can learn from the data. So one definition is also very much popular by this Tom Michel, who is a famous author of this machine learning book. So in this way means there are many ways of defining this machine learning, and universally there is no one definition is uh, acceptable. So there are many definitions of this machine learning, but the gist of all this definition is machine learning is subset of this AI, and which focuses on how we can learn or how we can train the model with the help of data. So where when we use this machine learning, so there are some situations like where human expertise does not exist, then we can use this machine learning. Suppose we want to do some tasks, very few examples are available, and it is very difficult for a human being to extract some new thing out of this. Then if human expertise is not available, in that case we can use this machine learning algorithm. Sometimes if you are not able to explain, our expertise lies where human brain is superior in many cognitive tasks like voice recognition, face identification, vehicle driving, and all these things. So but we are not able to explain how quickly we are able to identify someone's voice immediately, how we can identify our known faces. So in such type of scenario where some explanation of our expertise is required, we can use these machine learning solutions, or the solution changes in time. Sometimes solutions are changes like routing on a computer network, or browsing history of a user, or driving. So we have to be, and sometimes the solution needs to be very adaptable. Mm. So there are maybe some adoption like in biometrics, speech recognition, this spam filtering. Like spam filtering, many times if the spammer will change the rule, then we quickly our program should learn it, or getting insights about the complex problems and large amount of data. So in nutshell, when we required a generalization from past experience in a non-obvious way, we should use machine learning. Then there are many tasks like calculating payroll, sorting of list of words, web servers, word processing, where this learning is not involved. So means it is not that everywhere uh, we can use this machine learning. Calculating payroll, we have to do calculation. Some popular examples, the more recent examples are these large language models. Actually, they are the extension of NLP. But yes, learning is also involved. A huge training is involved in that, like the cost of training this chat GPT is or GPT-4 model is around $100 million. At the same time, the cost of this DeepSeek LLM is very low. So nowadays, but earlier there are more simple use cases of machine learning. Like every day we are using this spam filters. Now all email services are integrated with this small spam filters. What is the role of this spam filters? They can segregate the spam emails from ham mail or actual emails. Mostly 90% of the time, or 95% of the time, or sometimes 100% of the time. So automatically this on the basis of the content or subject, or on the basis of the email ID used, these filters are automatic. There are many other uh, uh, this extension of machine learning techniques are integrated in this mail service, but this spam filter is very much popular. At the same time, like in entertainment, we are every day now the in place of conventional entertainment, mm, uh, people are there are many examples like our this Netflix, Spotify for entertainment field, the self-driving cars, the facial recognition services used by this Google Photos, Facebooks, and this game playing, this DeepMind is pioneer in developing the games which are much more superior than the human players, personal assistant. So there are many examples in our day-to-day life, uh, the use cases of this machine learning. So what are the reason for the growth of this machine learning? So every day we are getting some new improvement over the past models. So almost one or slightly more than 1 year, this GPT-4 and this Chat GPT was a superior model. But within a 1 year, there are many more superior models are available, even in fact from OpenAI also. So every day we are getting the improved learning algorithms. Then second thing is availability of open source ML libraries. So most of the development very soon they release as open source, so it is available for experiment to all. Like this DeepSeek LLM is open source. Anybody can use it. They can customize it as per our need. So otherwise, it is very difficult to write these big softwares, big complex softwares. So this is the availability of open source libraries for this ML application is also the one of the important reason for the growth of this ML application. Then the parallelly the improvement in the data capturing technologies, networking, and this faster computers. So parallelly, this because data is a mandatory, so data nowadays capturing data is available very easy. Mobile phones, different types of sensors, or different types of social medias. This networking is also very fast. Computing is very fast. Earlier, the computing which was available with servers is not almost available with mobile phones, and new types of new sensors, smell sensors, or whatever input we want to capture. So different types of sensors are available, input output devices are available, and there is a huge demand for self customization to the user environment. So these are some few reasons which are propelling the growth of this machine learning field, like the continuous improvement in the algorithm, availability of the open source libraries, improvement in the data capturing and networking and computing devices, development of the new sensors, and the demand. This is uh, some popular tools, or we can say the libraries which are available for different purpose. And here you will see almost most of the libraries are open source, so we freely available. Like popularly we are using this scikit-learn, or this natural language processing libraries, TensorFlows, Keras, everything. If something is like proprietary, then their alternative open source is available. Like this MATLAB is comparatively costly, So Octave is equivalent to MATLAB. Whatever we can do with MATLAB, we can do with the Octave. So the point is, like, there are so many alternatives are available. If there is no, means it is not essential that you should be a good coder, then only you can work in machine learning. Everybody can easily start working in machine learning. At the same time, as I said, these machine learning techniques are divided into three basic categories, like supervised, unsupervised, semi-supervised, and further they are divided for different tasks. So here you can see the different machine learning algorithm, their sub-classification, as well as different algorithms. Like the supervised may be used for classification, may be used for regression, unsupervised may be used for clustering, association rule mining, anomaly detection. Everywhere, if there is a data, then we can apply this dimension reduction, semi-supervised learning, and the recently this reinforcement learnings. The supervised and unsupervised are somewhat saturated nowadays, but this reinforcement learning is very getting very popularity. And again, there are many algorithms, like in machine learning. Suppose we are using decision tree, so there are many alternatives of decision tree. So what it means, the message of this diagram is that how much options are available. So there are many examples, like our this Netflix, Spotify for entertainment field, the self-driving cars, the facial recognition services used by this Google Photos, Facebooks, and this game playing, this DeepMind is pioneer in developing the games which are much more superior than the human players, personal assistant. So there are many examples in our day-to-day life, uh, the use cases of this machine learning. So what are the reason for the growth of this machine learning? So every day we are getting some new improvement over the past models. So almost one or slightly more than 1 year, this this GPT-4 and this Chat GPT was a superior model, but within a 1 year there are many more superior models are available, even in fact from OpenAI also. So every day we are getting the improved learning algorithms. Then second thing is availability of open source ML libraries. So most of the development very soon they release as open source, so it is available for experiment to all. Like this DeepSeek LLM is open source. Anybody can use it. They can customize it as per our need. So otherwise, it is very difficult to write these big softwares, big complex softwares. So this is the availability of open source libraries for this ML application is also the one of the important reason for the growth of this ML application. Then the parallelly the improvement in the data capturing technologies, networking, and this faster computers. So parallelly this because data is a mandatory, so data nowadays capturing data is available very easy. Mobile phones, different types of sensors, or different types of social medias. This networking is also very fast. Computing is very fast. Earlier, the computing which was available with servers is not almost available with mobile phones, and new types of new sensors, smell sensors, or whatever input we want to capture. So different types of sensors are available, input output devices are available, and there is a huge demand for self customization to the user environment. So these are some few reasons which are propelling the growth of this machine learning field, like the continuous improvement in the algorithm, availability of the open source libraries, improvement in the data capturing and networking and computing devices, development of the new sensors, and the demand. This is uh, some popular tools, or we can say the libraries which are available for different purpose. And here you will see almost most of the libraries are open source, so we freely available, like popularly we are using this scikit-learn, or this natural language processing libraries, TensorFlows, Keras, everything. If something is like proprietary, then their alternative open source is available. Like this MATLAB is comparatively costly, so Octave is equivalent to MATLAB. Whatever we can do with MATLAB, we can do with the Octave. So the point is like there are so many alternatives are available. If there is no means, it is not essential that you should be a good coder, then only you can work in machine learning. Everybody can easily start working in machine learning. At the same time, as I said, these machine learning techniques are divided into three basic categories, like supervised, unsupervised, semi-supervised, and further they are divided for different tasks. So here you can see the different machine learning algorithm, their sub classification, as well as different algorithms. Like the supervised may be used for classification, may be used for regression, unsupervised may be used for clustering, association rule mining, anomaly detection. Everywhere, if there is a data, then we can apply this dimension reduction, semi-supervised learning, and the recently this reinforcement learnings. The supervised and unsupervised are somewhat saturated nowadays, but this reinforcement learning is very getting very popularity. And again, there are many algorithms, like in machine learning, suppose we are using decision tree, so there are many alternatives of decision tree. So what it means, the message of this diagram is that how much options are available, how much options, how many options are available in this machine learning field. So here you can see like the dimension reduction. If you want to do dimension reduction, then you can see here how many techniques are, number of techniques available for dimension reduction. If you want to learn this instance based, then alternatives are available. So the point is that this machine learning is also very huge field. Not AI is there, but this machine learning itself is a very huge, so very big, very large field. And here, then there are so many algorithms, so many alternatives are available. So how we can broadly classify this technique? So there are 3 4 ways of classification of machine learning model. So first principle is on the basis of the availability of data. The second is how we are getting this data. Third is like what type of models we are using. So these are some criteria of classifying these machine learning algorithms, because and these criteria are not exhaustive or exclusive. We can design our own criteria, But yes, these are popularly or widely adopted machine learning model classification techniques. So on the basis of the availability of the data, these machine learning models are divided into supervised, unsupervised, and reinforcement, and then further like hybridization of supervised and unsupervised, this semi-supervised, this active learning, transfer learning, this federated learning. There are so many options are available. So, and how we are getting this data online or offline? Offline means all data we are using together, or we are passing this data instance by instance, like we do in compilation or interpreter. So this is also one way of classification, how we are getting this data. And then what types of models? So there are basically two categories. One is generative models, discriminative model, or parametric model and non-parametric model. So first we start with this supervised learning algorithm. So in supervised is very popular, or very easy as well. As if anybody wants to understand the basic machine learning, then preferably they start with this supervised machine learning. If we compare to the what is going on recently, this is like the alphabets of machine learning. So this supervised means if the training data is available with label, then we can use the supervised learning algorithm. So here the training data can be of any, like it can be text, documents, or images, sounds, or medical diagnosis report, or anything. So first of all, we collect this raw data, and the domain experts will label this data. Suppose we are using this documents, emails we are using. So first we have to label this email, which email is a spam email on the basis of our expertise. And then suppose we have collected 10,000 emails, then we have to provide the 10,000 labels. This email is a spam, this is a ham, this is spam, this is ham, like this. Or out of this 10,000, 8,000 emails are ham emails, or means not spam, and 2,000 are spam emails. So every instance or every tuple should be labeled. Every instance, like every email, should be labeled. Then we will extract the features, like how we'll decide the this whether this email, or how any program will decide that whether this email is a spam or not. So there are features like if email contains like lottery, or some notice from RBI or CBI, or like this. So such type of unusual words are present in our email. So we'll prepare the list. So how we'll do it? We will extract features. So these are known as features. Like we extract the selected words from the email content, or email subject, or in fact email also. Like if email addresses itself is a good indicator of whether this email is a spam mail, or or non-spam email. So first we'll collect the data, then label this data, and then we extract the feature vectors. So these feature vectors are in case of email, these feature vectors are the different set of words, and these feature vectors are used to train this machine learning algorithms. So after training, these machine learning algorithms will be converted into models. So the difference between algorithm and model is the trained algorithms are known as model. Now we can test the same thing. Now we will not use the labels, and unlabeled data will be provided. We will extract the feature from the this unknown data, and this feature will be passed to this model, and now model will be able to assign the label. Like if you already use like Enron email dataset. So this Enron email dataset can be used for training, and then we can use our email, whether this email is a spam or ham. So this way is known as supervised. But again, how these labels are assigned? These labels can be assigned like either discrete values. There are two categories: spam or ham. So if labels are discrete, then the problem is known as classification problem. But if labels are continuous or real values, then problem is known as a regression problem. So this supervised learning is basically either it can be a classification or regression. So almost all algorithms will work as a regressor as well as classifier. So the difference is only if labels are available in discrete way. Discrete way, it may be 2, it may be 4, 10, 5, 15. Number it can be of anything, but it should be a discrete number. In regression, the labels will be like predicting a stock price or house price prediction. So stock price can be of anything. We cannot the stock price cannot be discrete. It can be of 10.1, 10.2, 10.3, 10.4. So basically these are real values. So stock price prediction is regression problem, and this if so both regression and classification both are supervised and vigilance. But in ideal case, here we can see like if we are taking only the example of 10,000. Sometimes the data may be available in millions instances or billions instances. So it is very difficult to exhaustively label all the instances because the labeling is done by the experts. Suppose we are considering the case of either email or this medical diagnosis, then who will label that whether this X-ray or MRI is representing some disease? Only doctors. So the cost of labeling is also time consuming, as well as the cost of labeling is very high. And sometimes if our problem is new, then labels may not be available. Like the recently in the recent past, the COVID, it was a new disease. So yes, there was related disease, but there was no labeled chest x-rays or the CT scans available for this COVID. So for such type of situation means in real life, there may be sometimes we will not be able to get the fully labeled data. And for that we use this unsupervised learning techniques. So unsupervised learning techniques may be clustering, maybe dimension reduction, association rule mining, or the probability distribution estimation. So there are many examples of unsupervised learning also. So in unsupervised learning also there is a the same email data will be there, but here the expert is not available. This email data is not labeled. So how we will do it? We will extract the features, and on the basis of the correlation between these features, correlation or similarity or dissimilarity, either way, in form of distance or distribution or any, for example, any mathematical principles can be used. So on the basis of this, we will form the group. Like suppose we want to, we don't have any idea about the different types of fruits, and all fruits are in a basket, and we asked to categorize. So what will do human brain as a human? What will do? Obviously, the same. We will look at the shape, we'll look at the texture, color, and on the basis of these properties, we will cluster, or we will form the groups of different fruit, or we will distinguish the fruits in this manner. So same sort of principle is applicable here. Only one thing, one difference. The feature vector is required here, but there are no labels. So again, we will extract the feature vector from the raw data. Like suppose we want to cluster the, we want to make the clustering of fruits. Then features may be the shape, color, texture, density, and all these things, weight, and all these things may be the probable feature of clustering these fruits. So in this way, we'll train the model, and again the same thing, this model can be tested on the basis of uh, unknown data. So this is the example. The same principle is applicable for dimension reduction. Dimension reduction is like this image compression. So what we are doing, we are replacing 100 image by 100 pixels by a single representative pixel. So we'll identify a representative pixel. Representative pixel means that pixels behavior is almost similar to its pixels available in its vicinity. So it can be considered as a representative. So 100 pixel can be represented by 1 pixel without the significant loss of information. Then this is known as dimension reduction problem. So in this way, we'll use this unsupervised algorithms. The third one is reinforcement learning. So as I already said that this there is a saturation from research point of view in supervised and unsupervised learning, because they are very conventional, or they may be used for simple use cases or to solve the simple problem. Still, they are very useful, and the companies are all using these basic algorithms. They are very fundamental to grab the concept of further. So they are equally important, but nowadays popularity, this reinforcement learning is gaining very popularity. So the working of reinforcement learning is slightly different from supervised and unsupervised. So in reinforcement learning, what is happening here, uh, the learning system will include the agent, and this agent will observe the environment, and on the basis of its environmental observation, the agent will perform the actions. So here there will be agent will assess the environment, observe the environment, and on the basis of the feedback of the environment, it will take actions. The action can be reward or penalties. If penalty means, reward means a positive, uh, and penalty means a negative response. So on the basis of, like, this reinforcement learning is very useful, especially in self-driving cars. So self-driving cars will assess the environment, like there are some input sensors are there. So traffic condition, road condition, and then traffic rules, as well as the available traffic on the road, and everything they will consider. And on the basis of this environmental signals, or this environmental, they will take action, either like reward means they use the accelerator, or they should use the brake. So in this way, there will be a policy will be formed, and in this way, like in game playing, especially the multiplayer games, where we have to increase the chances of our winning, as well as the same time in, like, in chess, and this AlphaGo, and there are many examples of this use cases of this reinforcement learning. Here also, this diagram is self-explanatory how this reinforcement learning will work. So this is the another type of learning. Then technically, this parametric and non-parametric models, as we have discussed, there are many models are there. So some models are very simplistic, like they are non-parametric model. Non-parametric model means, uh, for this more non-parametric model, they do not require the prior data distribution, or we can say the prior knowledge of the data. They simply learn from the instances. Like one example of this KNN algorithm. It's a very simple algorithm. So this is an example of non-parametric. It non-parametric means, it doesn't means that there is no parameter in algorithm. This is the misconception that sometimes people interpret the non-parametric means absence of parameter. Parameters are there, but algorithm will learn from the data itself, not on the distribution of data. Or so what will happen here, the quantum of data, if data is more, then learning will be good. If data is less, then learning will be poor, like this. And parametric means, rather than learning from the instances, they will learn from the distribution of the data, what type of distribution this data is following. Or like example of neural networks. So in neural networks, the network will learn the weights. Once the weights are saturated or weights are converged, then this model will be converged. So it will not depend on number of examples. If whether you increase or decrease, once your parameter will learn, then the quantum of data will not play a much role. So this such type of models are known as parametric model. So parametric model means constant number of parameters independent of training data. Means But in non-parametric model, number of parameters grow with the number of training examples. If more training examples, then the learning will be good. Strong assumption about the training data. There are no assumption about the training data. Simply it will learn from the data. Fewer training samples are required. Many training samples are required. And this parametric model learning is models are comparatively fast. And these are lazy learners, or we can say non-parametric models are lazy learners, slow training and slow inference. So these are some example like linear regression, logistic regression, neural network. Here, the decision tree, k nearest neighbor. These are the examples of non-parametric. Similarly, nowadays this uh, generative, discriminative and generative. So rather than going to the much technical detail, the discriminative models, how they work, what they will draw a discriminatory plane between the different types of input. Suppose our input is two-dimensional, then they will draw a discriminative line. So one side of line is one type of instances, other side of line is other type of instances. So discriminative lines, these discriminative models will learn the discriminative planes. The discriminative plane may be depending on the what type of data is available. If data is two-dimensional, then it can be a line. If it is three-dimensional, then it can be a hyperplane, or it can be a four-dimensional, then it can be a hyperplane of 3D like this. So the basic principle is the learn the decision boundary between the different types of classes. So how they will learn? By maximizing the conditional probability or directly estimating this conditional probability. But the discriminative models cannot generate the new data, and they are specifically used for classification tasks. And one popular example of this discriminative model, there are many others, but this support vector machine is example of this discriminative model. At the same time, there are generative models. So rather than drawing a uh, discriminative decision boundary or discriminative line or plane between the different types of input, they will learn from the data distribution, and uh, they can generate the new examples, they can generate new instances, and they will also learn the maximizing the joint probability, and estimate the conditional probability to find this conditional probability using these Bayesian rules. And they can be used for classification, but preferably these models uh, uh, these models are for to generate something. So generative models are, we can say, the more powerful because they can perform the discriminative, they can uh, exhibited the discriminative properties also. So examples are this Gaussian mixture model or hidden Markov model or this linear discriminatory analysis. These are the examples of generative model. So these are some basic classifications of machine learning. Hello. Hello.
Yes, sir.
Okay. If anybody has some question, then please you may ask.
Okay, okay. Sure, sir.
So far we have covered what is the philosophy of this machine learning, and what are the main different types of machine learning algorithms are there. There are many other categories like transfer learning, this privacy preserving or federated learning. So anybody? Okay. So we'll move next. Uh, so this is the general diagram. So first we have to take any real life problem, then the real uh, problem can be formulated, in a ML problem. So here we require two. One is domain expert. Suppose we want to detect the credit card frauds, or we want to detect the some anomaly in or some attacks in network, or means the activity which are very rare. So first we have to understand what is this problem, what when this occurred, what type of what how it will behave. So we required domain knowledge. We cannot apply machine learning algorithms, especially these plain machine learning algorithms, without the domain knowledge expert. Then we have to apply this feature extraction technique on raw data. Then we will collect, suppose we want to solve the problem of this fraud detection. Fraud means fraud can be anywhere, so this credit card fraud detection. So first we have to collect the sufficient number of instances of credit card transaction. Then we consult with the financial experts which transactions are flagged as a fraud, and then we extract the feature from this raw data, and then prepare the training and label which transactions are fraudulent transactions, and then we'll train the learning algorithm. So in this way, the domain knowledge as well as feature extraction, these are the two key points of the supervised machine learning algorithms. And ultimately, as a problem, will reach to this, like we have extracted many features and added them label, and then we can perform the test. So this is the basic work of how, like this is another way of representing the same thing. Is first we have to extract label from historical data and label all these instances, and then train the algorithm, then model, and now we can test the model. And this is the overall, you can say, the diagram for overall process diagram or supervised learning framework. How we'll use the training data, then different type of EDA like data cleaning, data curation, redundant data removal, and pre-processing activities will be performed. And then we can analyze the data. Like here age is given on some different scales, so normalization, or some, if there are too much dimensions are there, then we can reduce the dimension. So in this way, first step is to perform EDA as well as pre-processing, and then we divide our data into training and testing sets. So general, there are three types of sets are used. One is training, another is validation, and third is testing. So the rule is 70 10 20 or 80 10 10. So it's a thumb rule we can use. So 70% data is used for training, so we'll not expose this data to the model. The remaining 30% will not expose to the model. It can be used for validation or it can be used for testing. So validation means validation is used for the performance tuning of the model. So we can test for which parameters this model is performing best. So this is known as the hyperparameter optimization. So there are parameters and hyperparameters. So parameters which are essential for any model, hyperparameters which are not essential, but if this the value of these parameters are properly optimized, then model performance can be improved. So one is like a need, another is like luxury. So this hyperparameter optimization, we can use this, and for that we different cross validation techniques are used. Different for optimization, this different random search, grid search. These methods are inbuilt within the, and we can perform. We first will do the training, then validation, then testing, and we measure the performance. If we are solving the regression problem, then performance measures will be like the mean root square, then root mean square error, then R square, adjusted R square. There are so many measures are there. Similarly, if you are solving the classification, then model performance can be evaluated by accuracy, precision, recall, MCC, specificity. So there are different types of measures are there. So in this way, this is the summary how these algorithms will work. Now, I will take a simple example. Hello.
Yes, sir.
How much time I have actually? I want to take one numerical example, if time will permit. Otherwise, I will discuss some more recent advancement and can conclude it.
Sure, sir. As you wish.
So, how much time is available?
Sir, 15 minutes.
50 minutes.
15,
15.
15, sir. Yes, sir.
Okay. So, 15 minutes. I would like, because your the title of your talk is I'm not aware about who are attending, whether these are faculty members or research scholars or students. So, I would like to skip, and for 15 minutes, I just want to discuss the emerging areas rather than discussing particular algorithm or example. So, like, these are the typical example how this machine learning algorithms will work. So, as evaluation methods are there, like suppose for any machine learning algorithms, we are talking about the supervised especially. So we use these evaluation methods. So there is a holdout set. So available data is divided into two disjoint subsets, like training for learning a model and testing for testing the model. Or it can be, ideally it should be in three: training, testing, and validation. So uh, we can use the different, like, n-fold cross validation. What is this n-fold cross validation? So the available data is partitioned into n equal size of disjoint subsets. For example, suppose we have 10 instances, 10 data samples. So what we'll do, uh, uh, 10, this 10 data, out of these 10 data samples, we'll use at a time, we'll use 9 data samples for training and the remaining one for testing. The next time, the different 9 data samples and the one sample, different one sample will be used for testing. In this way, we will run our experiment. So this process is known as cross validation. Means every time, means generally in the machine learning experiment results will not trust on single iteration. So this experiment will be conducted on 10 times. Every time what we are doing, we are holding one and using 9. So next time, that one will be mixed with the data and the another unique one will be holded. Unique sample will be hold out. So in this way, this experiment will be run 10 times, and whatever the performance measures we are using will record all these performance measures, and then we'll do the averaging. Like 10 times we run experiment, every time you will get the different accuracy. So your model will give. So use each subset as the test set and combine rest n minus subset as the training set. And in this way, so generally we use 10-fold cross validation or 5-fold cross validation. So this is why we are doing this cross validation. Why we use this cross validation for evaluation of the model performance. Anybody? Why we use cross validation? So the objective of this cross validation is to avoid the overfitting of the model. Ultimately, the main objective of training is after training model should exhibit the generalized performance. If our training is superficial, so we cannot generalize. Like, you have only sometimes, as a human we also draw a general conclusion on the basis of a very small sample. Suppose I met with 3 persons from a particular state, and out of these three, if two's behavior is not as per my expectation, and draw a conclusion that that state people are not good. It's means the conclusion is not generalized, because the sample size was very small, or whatever. Means as a model I am overfitting. Means, so the that's why, to avoid this overfitting, we use the cross-validation techniques. So our model should exhibit the generalization. Another, the rigorous technique is leave one out cross-validation technique. So in this leave one out cross-validation technique is not very generic. It's used only for a small data. So it can be a special case of this cross validation, tenfold cross validation. So in leave one out cross validation, what we'll do, each fold of the cross validation is only a single test example, like we have discussed, because in earlier what we have considered only 10 examples. So out of 10, this leave one out can be applicable. But if suppose we are using 10,000 examples, then this leave out cannot be used there. So what we'll do, in 10,000, we'll use 9,000 at a time for training and 1,000 will remain for testing. But in this leave one out cross validation, what we'll do, we will keep test every single holdout instances. So for small sample or for small size data, it can be useful. Obviously, the this leave one out cross validation will give best example. So this parameter hyperparameter. Then the very popular this confusion matrix, which is also the cause of confusion for many people because they try to learn it. So here, there are two things. All these whatever we are talking is only in context of supervised learning, because for unsupervised learning measures are different. The way of working of these models is totally different. So here, there are actual values we have, and our model will predict something. So this is 2 cross 2 confusion matrix. So confusion matrix is nothing but data structure, n cross n data structure. Here we are using two classes, so it's for binary classification we can use this 2 by 2 confusion matrix, we can use 3 by 3, we can use 4 by 4, or in general we can use n cross n confusion matrix. So it will depend on the how many number of classes we are dealing. So here, there are two class, positive and negative. So we have number of samples, positive samples as well as negative samples. So we trained our model and our model will predict something. So on the basis of the prediction, what we are getting, we will get four types of values: either true positive, false negative, or true negative. So what it means suppose our actual value is positive and model is also predicting it positive. Then such type of instances, such type of known samples are known as true positive samples. But actually they are positive, but model is predicting them as negative. So model is doing wrong. So it's known as false negative. Model is doing false, so these are known as false negative. Actual are negative and model is predicting them as positive, then these are false positive. If actual are negative and model is also predicting them as negative, then these are known as true negative. So in this way, suppose we are using 100 samples for testing. So this 100 will be divided, means the sum of TP, FP, TN, FN will be, it should be 100. Sometimes if we are using our test set is of 100 instances, then the total sum of confusion matrix should not be more than 100, or exactly it should be 100. So out of these four values, this true positive is okay, because whatever the actually positives are predicted as positive, actually negatives are predicted negative. So these are the correct results. But this false positive means the result was actually it was negative. Means if we went for a particular test and that there was no uh, footprint of that disease in our body, but the test predicted as positive. Like we went for COVID testing, and although we are not COVID, we were COVID negative, but model predicted as false, model predicted as positive. So such type of cases are known as false positive. So these false positives are known as type 1 errors. The same similarly, these false negatives are also known as type 2 error. Means false positive and false negative. These are the errors. These are the errors, and we should reduce such type of errors. So where we have to focus, it will depend on the problem. Suppose we are solving a medical problem, like we are doing the screening the COVID patients. Then which one is more important? If suppose someone is not COVID negative and we are predicting him as a COVID positive, then the next state test will be carried out. But if it is positive and it is declared as a false negative, then that patient may be may be discharged from the hospital, and possibility he or she may spread the disease. So the cost of false negative is very high in such type of cases. So it will depend on the problem. What we should focus on, minimize the false positive or false negative, and depending on these, how we can minimize the different types of evaluation measures. All evaluation measures are not, means randomly we cannot use any measure anywhere. So different types of measures are there, like precision. So precision is what? Precision is like number of correctly predicted positives out of total positives, means TP upon TP plus FP. So predicted positive is TP, and total number of positive predicted positives are TP plus FP. So if we'll reduce the FP, if we'll increase the TP, then obviously precision will also increase. If we want to, if false positive will increase, if false number of false positives will increase, means the number of this type 1 error will increase, number of instances will come here, then the precision will be decreased. So it will means in which case we require the high precision. And the same is sensitivity or recall. So sensitivity or recall is nothing but like the number of actual positive divided by total positive. So TP upon TP plus Fn. Here, if we'll increase the false negative, then our recall or sensitivity or true negative rate will be increased. True negative rate will be increased. And the accuracy will be simple. Total number of accurate, so total number of corrects are TP and FP, TP and TN divided by all TP plus TN, FP plus FN. So in this way we can derive the different types of measures. So rather than remembering this confusion matrix, simply now we can change, like predicted can be changed to the actual. Actual can be, means column can be actual and the rows can be predicted. In that case also, on the simple principle, we can derive the different measures. So apart, these are the basic measures. The similarly, we can find out the false positive rate, true positive rate, false negative rate, true negative rate, MCC. There are many measures can be derived, all from this confusion matrix only. So because accuracy in many problems, this accuracy cannot be useful. Like this, sometimes the high accuracy does not mean any. Uh, suppose we are detecting the frauds. So frauds are rare as compared to the normal instances. Suppose 1 million transactions are there, and out of these 1 million transactions, only 10 are fraudulent transactions. So even if your model is not working proper, then it will give you a more than 99 point accuracy, 99, more than 99% of accuracy. But this is not correct. So sometimes this accuracy is misleading, or accuracy is not suitable in some applications, like where data is highly imbalanced, means one class is dominating the very much dominating the other. Like out of 100, if 99 samples belongs to positive and one sample belong to negative, or 99 samples are negative and one is positive, then irrespective of your model performance, you will always get the result 99%. Accuracy, at least accuracy will be 99%. That's why these different measures are preferred. So, as I said, that the precision and recall are used. Like this recall is important. The recall is important in this medical, where we want to capture more and more cases, so nobody should leave. So there are many examples, like if suppose we have deployed a crowd uh, surveillance system, ML based crowd surveillance system. Then, if suppose somebody who is not suspicious, but our system will flag him or her as a suspicious, then worst case, what will possible? Yes, once again he or she will go. Normally, it happens to airport very frequent. That again frisking. Then they will confirm and release itself. But it cannot be. We cannot afford this cost in case of medicine. Like in case of this spam filtering, if suppose some spam will deliver, some spam email will deliver in our mailbox, then it will not harmful for us. But just because of too precise rules, if any important mail may be delivered to spam mail, then it may be our interview call from unknown, first time they are communicating with us, so it may be delivered to, then it may means we may lose the opportunity. So where we have to use precision, where we have to use recall, this is the problem specific. And sometimes in some problem, because precision recall are, there is a trade off, like time space trade off. So if we'll improve the precision, then recall will be down, and if we'll improve the recall, then precision will be down. But in some problem, we need both recall as well as precision. So how we can use these together, and for that we use a new measure which is known as F1 measure. So F1 measure is nothing but the harmonic mean of precision and recall. Why harmonic and why not algebraic or some other mean? There are different types of means are there. Harmonic mean because if suppose there is a precision is high, then if we will not take harmonic mean, and in place of harmonic mean, if we take some other type of mean, then the higher value will dominate the f. But here our objective is, we want to keep both precision and recall. In some problem, precision and recall should be balanced. So that's why we are taking this harmonic mean. So any large value of either precision or recall will not dominate the f measure. So that's why we're taking the harmonic mean of. So this f1 measure or f1 score or f1 value is nothing but representing both precision and recall in a single measure. Similarly, there are many other measures, like I said, that we can calculate the TPR, FPR, and we can plot this TPR, and we can this ROC, receiver operating curve, ROC AUC, area under the curve, we can calculate the area under. So here you can see there are two classifiers, C1 and C2. So which will be better, which will cover the more area will be better, like this. So in this way means there are different types of measures are used. One, I will make few quick points. Okay, this time is over. Hello. Hello.
Yes, sir. We are at the end, but if you have some more things to
Yeah,
discuss,
quickly.
surely.
I will just.
Yeah.
I'm not going in depth. I will just the quick points. So
Okay.
as we have discussed nowadays, like deep learning. So what is the difference between machine learning? This question is always arise. This, what is the fundamental difference between machine learning and deep learning? So the core of machine learning is feature engineering. Means we have to identify the feature as well as to extract the feature. Like identification of the feature, suppose we want to classify the fruits, different types of fruits, then it's these features are handcrafted. Means like we have to identify whether we are going to consider the shape, or if all fruits are of same shape, or we are going to consider the texture. Then means The point is, in machine learning, the feature engineering is very important. So first we have to, with the help of experts, we have to devise the number of features, relevant feature. Irrelevant feature it will not contribute, only they will enhance the model complexity. Suppose we want to predict the student performance, suppose this particular student will be placed in final year or not. And so there are many attributes or many features are there. And we are taking the height and the weight and color. So for his placement, these features are not contributing features. These features may be useful for some sports or some other activity, but placement, his academic performance is more important, his academic aptitude or whatever we means related to this. So feature engineering is important in case of machine learning. And in deep learning, there is only difference. Deep learning models are also supervised, unsupervised. But in deep learning, this feature extraction is automated. This feature engineering is automated, not only feature extraction. Means they will identify the feature as well extract the feature. Although they will, these features are very complex. That's why these deep learning models are not very much explanatory. Means they will give good result, but you will not able to explain why we are getting the good result. Okay. So this is the basic difference between machine learning and deep learning. So in deep learning, this feature engineering is automated. Automated is taken care by the model itself. While in case of machine learning, these feature engineering is features are handcrafted, and we have to write the code program because we have designed these features. Although this task will be automatic in deep learning models. Means when we apply the CNN, it will extract the very complex features from the any image. So this is one thing, and this is how, again, same diagram, this artificial intelligence machine learning can be supervised, unsupervised, and reinforcement learning. So the similarly, the deep learning can be of anything. Deep learning model sometimes means unnecessary confusion, like this deep learning is always supervised. No, the CNN is supervised, but at the same time, this autoencoder, decoder, these are the unsupervised. So deep learning can be of supervised, unsupervised, or reinforcement learning. That's like the Q learning and anything. All these are the reinforcement. Sorry, this deep learning reinforcement learning. So one thing is this, and this transfer learning. So I will not touch this more. Yeah. Uh, One thing is this transfer learning based model. So nowadays you will find many pre-trained models. Basically, what is the idea of this transfer learning? Transfer learning is means the learning of one task can be uh, uh, help to learning in others. Like suppose you may heard about the ImageNet competition. So what is this ImageNet? ImageNet is a data set. Millions of images are there. Different types of images are there, and some convolution networks or their variants are trained on this. And we can use this training for our. Suppose we want to design a, uh system for image classification. Then we can take this because the basic features are same. So basic image features like curves and the angles, these are more or less same. So we can customize some layers, and like suppose you can, I'll just give a simple analogy. Like if we know, if you tractor driving, then it is comparatively easy to learn the car driving. Although tractor and car totally different, but you have confidence or learning aptitude of uh, how to handle the steering, when to use the accelerator, when to use brake. So this knowledge can be transferred in car also. So this transfer learning is also getting popularity, and there are many pre-trained models are available both in field of computer vision as well as in field of NLP. So in NLP, like whatever we have discussed, there are so many models are there. Transformers earlier, their BERT was there. Then this glow, word to wait, and there are many. So all these are similarly these VGG, ResNet. These are nothing but these CNN based pre-trained models. We can use any of the model, customize it, and fit into our problems. At the same time, these transformers, all these are pre-trained models. Pre-trained means already they are trained with the huge amount of data, and we can customize few layer and we can use them. So this is the brief history how the development is going on, in especially in NLP. This is the brief overview of in last 10 12 years where we have reached, especially in case of, and all these, like in 24 we have example of this we have discussed in starting, and recently 1 week before this DeepSeek was released, and how they've changed. And another model like this DALE. So in the same image generator, text to image generator, like we will give the text input and model will generate the output. So the DeepSeek has also released the superior model than this DALE. So there are so many things are happening, so we'll not discuss. You may be aware about of what is going on in this field. And on top of that, the 24 the Nobel Prize winner of 24 were the AI inventors. This John Hopfield, you heard about the Hopfield network, and this Geoffrey Hinton. These are very popular. So physics Nobel Prize winners are from AI. So there was a debate, means why these AI people are getting physics Nobel Prize. So there is a correlation, a strong correlation, or the many, like this restricted Boltzmann machine or Boltzmann machine and the contribution. So on the basis of this, they, and you can see the summary of that, what is the contribution of Professor JP have written, how they have contributed from starting the Boltzmann machine to the now this transfer learning models and everything. Similarly, the chemistry Nobel Prize was also given to the AI applications. So first was for AI invention, and second was for, you maybe heard about this AlphaFold. So what is this AlphaFold? Is AlphaFold is nothing but trained system which can uh, earlier that was a huge problem, means there are so many proteins are there, and every protein has its own structure, and to know the structure of protein for further use in disease, drug discovery or for anything, it was very difficult. So this AI has solved this problem permanently. Now every structure of every protein is known. Even unknown proteins, easily you can single click, you can know the structure of this protein. So that's why this John M. Jumper from Google DeepMind, along with other colleagues, they received the Nobel Prize of Chemistry. So the Chemistry Nobel Prize was given for application of AI, like this AlphaFold 2. So I think this is all over from my side. If you would like to ask something, then you are most welcome. Hello.
Participants, yes.
There are many other uh, uh, this extension of machine learning techniques are integrated in this mail service, but this spam filter is very much popular. At the same time, like in entertainment, we are every day now the conventional in place of conventional entertainment, mm, people are